Another system commonly found on high-performance aircraft is retractable landing gear. Retracting the gear streamlines the airplane and reduces parasite drag. This leaves more power available for better climb performance and higher cruise speeds. There are many different types of retractable landing gear, from the types found on large commercial transports to those on high-performance single-engine aircraft, with each one being identified by the power source used to extend and retract the gear. In this section, we'll look at the most common types of retractable landing gear systems: the electrical and the hydraulic. In both the electrical and hydraulic systems, you control the position of the gear by a landing gear lever located in the cockpit. By moving this lever, a signal is sent to the power source, which in turn supplies the necessary energy to raise or lower the gear. One thing you always want to do is verify you're moving the correct lever. Even though the gear and flap levers are shaped differently, a few pilots have thought they were raising the flaps, but inadvertently raised the gear. To prevent this from happening, most manufacturers have included a safety detent in the lever assembly. In order to raise or lower the gear, you must lift the lever over this detent. When transitioning to a different aircraft, make sure you're familiar with the layout of the controls. Some aircraft have the location of the gear and flap handles reversed. The first type of system we'll examine in detail is the electrical gear system. In this particular aircraft, each landing gear is mechanically linked to a gearbox, which is located in the fuselage just behind the pilot's seat. By moving the gear handle, power is supplied to an electric motor, which drives the gear toward the selected position. The motor will keep running until the up or down limit switch on the gearbox disconnects the electrical power to the landing gear motor. Should the gear fail to extend due to loss of electrical power, it can be extended by using a manual hand crank located on the floor in front of the pilot's seat. When the emergency handle is placed in the operating position, it automatically disengages the landing gear motor from the actuator box, allowing you to hand crank the gear into the down and locked position. However, because of limitations on most systems, the hand crank cannot be used to retract the gear once it is down and locked. The next system we'll look at is the hydraulic landing gear system, which uses an engine-driven pump. In most cases, the pump is located on the accessory section of the engine and uses a series of valves, pipes, and hydraulic actuating cylinders to transfer the hydraulic fluid necessary to raise and lower the gear. This system also has an emergency feature should an engine or hydraulic pump fail. Backup hydraulic pressure can be supplied by an electrically driven hydraulic pump, or in the case of some small general aviation aircraft, by a hand pump. In the unlikely event of a hydraulic leak or loss of hydraulic fluid, some aircraft have tanks of compressed air that may be used to blow the gear into the down and locked position. Another type of retractable gear is the hydraulic system, which uses an electrically driven hydraulic pump. This system is referred to as an electro-hydraulic system. Pressure in one direction raises the gear and holds it in the up position, while pressure in the opposite direction lowers the landing gear. Most hydraulic systems have an internal pressure switch, which automatically operates the hydraulic pump when system pressure falls below a specified range. This pressure is supplied to hydraulic actuator cylinders, which are attached to the gear assembly. These cylinders do the actual raising and lowering of the gear. In some systems, the gear is held up with hydraulic pressure. However, some manufacturers also use hydraulically actuated uplocks to hold the main gear in the up and locked position. In addition to hydraulic pressure, some aircraft have a heavy-duty spring attached to the gear assembly to help extend the landing gear into the down and locked position. To prevent inadvertent retraction of the gear during ground operations, most systems incorporate a mechanical squat switch located on the landing gear strut. When this switch is compressed by the weight of the aircraft, it does not allow the gear to retract. However, if the gear handle is in the up position and pressure is removed from the switch, the gear attempts to retract. This could be especially hazardous on takeoff. During normal operations, the gear should be retracted only when a positive rate of climb has been established and you can no longer land on the remaining runway. The emergency extension for an electrohydraulic system may consist of a pressure dump valve which relieves system pressure and allows the gear to free fall into the down and locked position. On most aircraft, a hand pump is required to supply system pressure for lowering the gear. To determine the status of the gear, indicator lights are installed. There can be one or more lights located near the gear handle. When the gear is down and locked, a green light appears. Gear in transit or in any other position besides down and locked may be indicated by an amber or red light. In most aircraft, these lights can be dimmed. This prevents them from becoming a distraction during night flights. In this example, rotating the light itself reduces the brightness. Some landing gear indicator lights have a push-to-test feature, so you can quickly determine if the bulb is burnt out. Another way to determine if a bulb is burnt out on systems with more than one light is to switch the bulb with one that is already illuminated. Most systems are set up so that all of the gear lights are interchangeable. In this way, you can quickly determine if the problem is in the lights or the gear itself. Some aircraft also incorporate a small mirror to help you visually determine if the gear is down. Another feature found on most retractable gear aircraft is a landing gear warning system. This usually consists of a warning horn that sounds when the gear is not down and locked, and the throttle is reduced below a specific point. A similar system also alerts the pilot that the gear is not down and locked when the flaps are lowered beyond a specific flap setting. The gear on some systems automatically extend when the airspeed drops below a designated value. This system also prevents the gear from retracting when below this airspeed. These auto-extension type safety features may be disarmed so the aircraft can be maneuvered with the gear up at slower speeds. For example, this system must be overridden in order to retract the gear during a maximum performance takeoff. Due to the forces imposed on the landing gear by gravity and the airstream, manufacturers have designated a couple of airspeed limitations for landing gear operations. The first is maximum landing gear operating speed, or VLO, which is the maximum speed that the gear may be safely extended or retracted. The other is maximum landing gear extended speed, VLE. This is the maximum speed you can fly with the landing gear in the down and locked position. These airspeed limitations are not shown on the airspeed indicator. However, they are listed in the pilot's operating handbook as well as placarded on the panel. Exceeding these airspeed limitations can cause structural damage to the aircraft and to critical landing gear components. During cold weather operations, slush and ice can build up on the landing gear assembly. To help prevent this from happening, try to avoid taxiing through standing water prior to takeoff. After takeoff, if there is a chance that moisture is on the gear, leave it extended slightly longer than normal to allow the air to blow it off. In this volume, we have taken a look at some of the components of high-performance aircraft, including fuel injection and how it improves the power output of your engine through better fuel distribution. Next, we looked at how constant speed propellers allow you to alter propeller blade angle to obtain optimum performance throughout a variety of airspeeds, and how turbochargers help your engine develop maximum power at altitudes well above sea level. We also learned how environmental systems can help you and your passengers remain comfortable during high-altitude flights, and how ice control can provide an additional safety margin during IFR operations. And finally, we saw how the components of different retractable landing gear systems work together to raise and lower the landing gear. Remember, each make and model of aircraft has its own distinct operating characteristics and design features. These advanced aircraft systems require you to study the pilot's operating handbook in order to thoroughly understand the different systems and take full advantage of their benefits.